Hi guys, I'm Darren, and in this video we're going to be checking out the new SpeedyBee F405 WING MINI flight controller. So I'm sure this is something that a lot of people are into. A lot of people are flying smaller planes these days, and having a flight controller that will fit in there a bit easier than a big one is definitely a necessity. At the moment there's not really a lot of choice. We have maybe the F405 WMN from Maytech. There's an F405 Navi Mini from Atom RC, but other than that, there's not really a lot of choice for small flight controllers. So let's see how this one stacks up, and we'll also see if it's good for light aircraft too. Before we get into the box, let's have a quick look on the manual. Now, at the moment, it's actually the flight controller is getting released today. It's Monday the 12th for me, early in the morning, or early-ish in the morning. So the actual flight controller is not on the SpeedyBee website at the moment, but they have sent me the manual and we can have a quick look through that. Top of the manual we have some QR codes, bit of general information. We see that it's got a wireless USB extender. We'll have a look at that later on because it'd be easier to show it and explain it. You can run iNav or RGPilot. It's got a 2S to 6S input, so 2S is great if you're on a lighter build. Gives you the dimensions and a weight of 19 grams. Which again is not too bad. It's not overly light though, so it may be that it's more suited to a small build rather than a light build. There's a couple of ways this flight controller can be installed, and the first one, or the standard orientation, is actually with the main PDB board on the top, which is a bit different to what we're used to. So on the bottom we have a shield board, which is just a bit of PCB board with the holes drilled in and cut to shape. Now if you're really on getting the weight low, you could probably replace these standoffs on the bottom with a nylon equivalent, so it just needs to be the same screw size and same height. But you can see in the middle we have our flight controller board, and they've put vertical pins in that. We can see later on there is an option. And then the top board is actually the Beck board with the main power inputs. Now when I first saw this I thought, that doesn't look right, but it's because it's not what we're used to. It may actually work out better, so it's giving you more choice. That's a great thing. You can get a basic idea of the layout from the board. You can see here we have an SD card slot, and you can see we've got a few connectors here, a few solder pads here, and as I mentioned earlier, the vertical pins. Okay, so the second installation option is actually up the other way. So the PDB board is on the bottom, so stuck to the bottom of the model, so more a traditional layout. Then we have the flight controller board, which is upside down in this case. And you can see here they've put angled pins. So the option is there to use angled pins or straight pins. And of course, it doesn't really matter which way up you have the flight controller, because the shields for the this top shield is the same size no matter which way up you have the flight controller. So you could use straight pins here, or you could use angled pins here. It's pure preference, whatever suits your build best. And then this top shield board, which in all honesty, you probably don't even need at all. If you're really trying to save weight, you could just not put these in and just screw this flight controller straight onto these standoffs using these screws here. So we've got a few assembly instructions. We won't go into that. Overview of the board. So let's see what we have. So yeah, as I mentioned, we have got a genuine SD card. Again, it's not really in a great position, but with a board this size, I'm much more willing to forgive stuff like this because you're very limited to space. I mean, it would have been nice if it had been facing outwards, so you could get the SD card in and out from the side. You know, it's just one of those things. On a board that's so small, we're limited to space, so they can only do what they can do with the layout. Right, so down the bottom we have our S-Bus UART. So this is basically going to go to RX2 with a little hardware inverter in between, because this is an F405, so there's no on MCU inversion. So if you're using an inverted protocol like S-Bus, you need the hardware inversion. Next along we have our motor and servos. You can see there's a little white border here separating out the motor, or the default motor options with the default servo options. course, in iNav 7, you have more control. You can choose which timers are used for motors, which timers are used for servos. So it, the order of this is down to how you want it, but this is the default layout. You can see we have VX here and a ground here. The BEC for the servos is actually quite interesting on this board. By default, it's 5 volt, but you can up it to 6 volt, so it's switchable. But you can see there's actually, I think it's 11 PWM outputs. So you've got the 9 with the regular DuPont connectors, and there are 2 pads for S10 and S11 on the other side of the board. So you can connect up to, well, it'd be 2 are used for motors, so you can have 9 servos. But if you're going to do that, read the notes, because you should actually power them from an external BEC. And the mechanism for doing this has been included with this board, which is a really nice touch. So there is a pad somewhere where we can disable the servo BEC, and then you can put a power in on one of these pads. I think it's if you're running more than 4 or 5 servos, then use an external BEC, but the mechanism is on here and we'll cover that later. So we've got the connector to go to the power distribution board. We have an analog input here for RSSI. Of course, you can change what the input is used for. We have here UART4, so RxTX 5 volt and ground. We have pads here for video, but yeah, so we have a VTX pad for video out. We have T5 for smart ports, we have ground, and we have our video voltage, which again is switchable. We can choose between 5 volts and VBAT. What I've not seen so far is if it's using the VBAT, is it filtered still? So that's one thing possibly to be aware of, but we'll see if it's mentioned later on. Here we have the analog camera input. Now you can see there's actually the option for 2 cameras, which is really nice. So there's camera 1 and camera 2 ground, and it's using the same power supply as the VTX. It just means you have to be careful with the voltage of the camera, and the VTX are both able to support VBAT if you choose to use that. So yeah, we have the option for 2 cameras that you can switch between, which I was always a fan of. It's really nice. As a note, the big one can't do that. Next pad here is UART3, so it's a 4.5 volt, so this would be ideal for something like a receiver or GPS. Anything that says 4v5 is using 4.5 volt. It can be powered when you've got your USB connector plugged in. Anything that's VX, VV or just 5 volt will need the battery for power. Next up we have this block here, which they're saying is for GPS. So again, that's using RX and TX3, which is exactly the same as these pads here. Having all that, it makes me think it's wasted space, if I'm being perfectly honest. The only difference between this and this is there's SDA and SLC for the compass, which could have been 2 pads. I understand why they're putting blocks on, because having it plug and play, some people like that. Personally, I'm not such a fan. Because at the end of the day, you're going to have to cut wires and solder stuff together anyway, because you're guaranteed the stuff that you get with your GPS won't just plug straight into that. You're going to have to make changes. But also on a board like this, if you want to keep it light, adding all these connector blocks, even adding stuff like DuPont pins, is adding to the weight. You're adding grams and grams here. And don't forget, the connector is on both sides of the cable. So for a DuPont connector, you could be adding, just for the pins and the actual connector itself, you could be adding 1 or 2 grams, which might not sound like a lot, but if you're doing a sub 250 gram build, it adds up. So all these connectors, they're a couple of grams each. These pins here, we can weigh them. They're not insignificant. On a light board like this, I'm not overly a fan, and I'm not a fan at all of basically this redundancy. This block here is basically wasted space because it's repeated here. You could put this block up in here, then you have all this space for something else. Maybe VTX power switching, which is more and more important these days. It was nice to have on analog, but with digital, I find it really important to have with digital, because you can switch the VTX off when you're waiting to get satellites. Not only does it stop the VTX overheating, but if there is some interference between the VTX and the GPS, you don't need to worry about it. Once you switch the VTX on, the GPS should have enough satellites to keep going. I'm not overly keen on all this wasted space. I'd rather just see this block gone, to be honest, and see something in its place. So let's continue with the other side of the board. And again, we have some more blocks. On this side, we have UART4 and UART2. So UART4, I'm sure I've seen already. Yep, so we've got UART4 here. So that is, again, replication. It's the same thing in two different places. But there is UART2. We have the VTX and camera stuff, which again is a replication of these pads here. But also we have this DJI block, which again is irrelevant. When you look at it, we have S-Bus, which fair enough, DJI uses S-Bus. It is over here, but DJI uses it. It's fair enough that it's in the block. We have a ground pad, ground, ground, right? So we have three grounds, basically all doing the same thing. We have RX and TX. We have TX here, so we're just adding the extra RX. We have another ground, which it seems like DJI has a ground loop potentially, but fair enough, we have another ground, and we have voltage. So why not get rid of these blocks here completely and add an extra maybe 2 pins to this block, or 3 pins because of the camera switching. So it would make this block bigger, but you'd still have half of this space left for something else. And all you'd need to do is to have different wires. So the plug that plugs in here, you'd have one that goes to a DJI system. They could also provide one with just bare wires that you hook up to your analog system. It means that you've wasted a lot less space, and you can still have your connectors if you want them. And you've got all this space that you could put something else. Last connector I actually think is necessary. So this is for the USB extender board, which is the little board that you get where you can plug a USB in. So this has got RX and TX, boot pin, buzzer, it's got D plus and minus for the USB, ground, and 4.5 volt. The RX and TX is because the wireless stuff is actually on that board, it's not on the flight controller itself. So that's the bottom of the flight controller board. What we should probably mention is the barometer is here. So what you might want to do is put some open cell foam over it. I know that the SpeedyBee boards don't generally come with open cell foam, but it does help improve the performance of the barometer. So however you have this oriented, you might want to put some open cell foam in. So now we get to the extender board. The SpeedyBee manuals I really like. They put all this coloured stuff on so that you can identify the components easier. It's really nice. So we have a USB-C connector, which is great. We have a big buzzer. We have a switch to turn the buzzer off, which is fantastic. We have a boot button, and we have this pin, or we have this connector block here, which plugs into this connector block here. So pretty standard. If you're used to the bigger SpeedyBee flight controller or Maytech flight controllers, you know how this works. What you probably can't see is on the bottom is probably the Bluetooth and the wireless stuff, but we'll take a look at that when we get it out. There's a little indicator here to show that wireless is active. Right, so the PDB board, you can see the connector block here and the main power blocks here. From the other image, the main power pads are on both sides of this board, which is great. There's not really a lot to go over on this board. We have a jumper here for the servos. So by default, it's 5 volts. If you bridge these two, there'll be 6 volts. We have a VX power supply here. So by default, it's bridged, which means that it's using this BEC here to power your servos. And if you want to use an external BEC, you need to unbridge these pads here. And that will disconnect this BEC system here from your VX power, which is your servo power running through this rail here. So you can connect an external BEC and power it whatever, however you want. You could use high power 7.2 volt servos, for example. Last one is we have the power source for the VTX. We have the 5 volt BEC, and we have a bridge to use VBAT. Again, it doesn't mention if it is filtered. Right, so then we get into the standard wiring diagram stuff. I'm not going to go over that because I'm guessing you know how to wire up a flight controller. If not, this diagram is great. It's going to show you exactly where you need to put stuff and how you wire it up. So here we have the power supply diagram. So we have the FC BEC, which is 5.2 volts, 2 amps, goes through a 2 amp diode through the 5 volt 4 pad. The diode is to stop the 4.5 volt going back from the USB into the BEC. We have the servo BEC, so 5 volt default, 6 volt optional, and a 4 amp maximum. So if your servos are drawing more than 4 amp, you definitely need to use an external BEC. So the output goes to the BEC power supply jumper and then goes to the solder pads. Now, interestingly, the output for the servo BEC also goes to the VTX BEC. So if you're using 5 volts on the VTX, you're actually using the servo BEC output. So again, filtering is coming to mind quite a bit. There's nothing here about filters. So yeah, so that's something to be aware of. If you do boost your servos to 6 volts, which pretty much on every build I do, I switch it to 6 volts because you get more torque and more speed for basically nothing. So yeah, that's something to keep in mind, but also worth keeping in mind that this 4 amps will also need to cover your video system as well if you're using 5 volts. So there's a couple of things to be aware of with that. I'd recommend that you read these instructions fully. Make sure you understand everything before you connect anything up. Everything for how you set this up is pretty much covered. It's a really good comprehensive manual. So take the time to read through it. SpeedyBee have obviously put a lot of effort into this, and yeah, it's well worth taking the time to go through this. But anyway, we've looked at documentation long enough. Let's have a look at the actual hardware. Right, so it's still sealed. I've not had a look myself yet. Other than I've seen this has actually been leaked quite a bit. As I say, it's not due for release until the 12th, which is actually today. But it's still not on the SpeedyBee website at the time of making this video. So let's have a look. Nice cardboard box. I do like their boxes. SpeedyBee are pretty considerate with their stuff. So we have a quick start guide, which actually the quick start guide is actually very comprehensive as well. It seems to cover a fair bit of what is included in the manual. So yeah, very good job, SpeedyBee. You can see the important stuff here, like the 2 different orientations for the installation, how you connect everything up. So yeah, great, excellent work. Let's have a look here. We have the PDB board, which, as we've seen on the diagram, it's got the information here for this UART, and it has the copper traces on both sides for the ESC and the main power. You can actually see some. I mean, this is the shunt. It's actually quite a beefy unit. So yeah, you can see VTX switch here. So it's set up to use the VBAT by default. And you can see this pad here on this side for switching the servos over to use 6 volts. So yeah, that's one thing I will definitely be soldering up. And down here you can see the pad for using the onboard BEC for the servos. So this here is the extender board for the USB connection. So you can see USB-C, big buzzer switch, a proper button for the boot, which I like. It's not just one of those little capped on tape buttons. We have a wireless LED there. Looks like we have another LED here, and the connector block. And on this side, this is what I was alluding to. We have the SpeedyBee wireless connector here. Is that an ESP chip? This side has all the wireless stuff. So all this stuff is not on this flight controller. So it means you need to have this connected to use either the USB or the SpeedyBee app, and of course the buzzer. But it means you can put this away from the flight controller, making access easier for if you want to use USB. So now the flight controller itself, and yeah, this is a reasonably small flight controller. When I first saw the specs, I thought it would be a similar size to the original F411 Wing, but it actually is a bit smaller than that. It's not quite F405 WMN size, It's a little bit bigger than that, but it's still a pretty small flight controller and will fit in quite a lot of small aircraft. I've basically covered the whole pin out of this. So by default, that is the top. And you can see it's reasonably tall. I think it's about 14 millimeters tall when you've got it all connected up. Oh, that's nice. So the foam, they've actually stuck onto that lid, so it's easy to pull up. So here we have some cables. Here we have some more cables, a capacitor and the top board. There we have our pin headers, and there we have our little standoff. So that's everything you get in the actual box itself. And again, yeah, this is, you've basically got everything you need. So let's take a look. One of the criticisms about the original board, which I believe SpeedyBee have actually addressed, was the length of the cable for the extension USB block. So I believe this is the cable for it. As you can tell, this is a much nicer cable length. My criticism was on the original one, which I have here. So I got this out to do a size comparison. The cable plugged in, where is it plugged in? Plugs in on the underside here, but when at full extent, the board only came to here with the cable that was supplied, which to me was pretty useless. People actually complained that I'd mentioned that in the review, but seriously, what's the point of a remote USB if it can only go within the length of the flight controller itself? This cable, on the other hand, is ideal. So yeah, SpeedyBee listened, improved their product. Excellent work. So while we've got this, that is the size comparison. So let's put it on the top plate, and because if you've got one of these original ones, you could probably get an idea for size. So if we put it on the top plate, it comes to, sorry, I'm being a bit lame here. So this bit of etching here on the bottom is where the width comes to, and the length is, I would say, the line in between the S row and the row for the power. Yeah, that looks about right. So this line here down to that line there, and that is the size of the Mini. So if you've got one of the original ones, you now have an estimation for how big this is. So yeah, we're looking at about the same height, maybe slightly shorter than the full size. What other cables do we get? So these are all different cables for the different types of connectors. You can see we have an open end here because this cable just has the little pins on, which these pins are actually a pain to crimp. So yeah, I'm glad they've done this. And that one is going to be the DJI connector. What else do we get? So here we have a single camera connector. Yeah, this is a 3-pin for a 4-pin. So that is a single camera, and that end goes into the camera. So if you're using dual camera, you will probably have to make up a cable yourself, unless this one will do it. But no, I think this is probably going to be the VTX. Yeah, so that's the VTX cable. So while they have put a block on here for 2 cameras, what they've actually given in cable only has a single, sorry, it would be this end, but it only has a single cable coming out for the actual camera itself. So if you're running 2 cameras, you will have to find another cable to connect in here. You'll have to splice the power in the ground so that the other end you have 2 connectors. So even though this block exists, you can't really use it as it comes out of the packet. You have to do modification anyway. And if you're going to do that, it's just easier to put blobs of solder on here. I'm hoping that you're seeing why I'm not a fan of connectors. A lot of times I hear that people don't like soldering. For me, in this hobby, a big aspect of it is actually soldering. So if you're not happy with soldering, or you're not confident with it, my advice would be get some test boards. You can get from different manufacturers, maybe even SpeedyBee. I'm not 100% on that, but I know definitely from Diatone. You can actually get boards that have got no components on it. It's just a PDB board with a load of solder pads on, that you can practice soldering on different size pads. And something like that, you'll get better at your soldering. You won't destroy anything because there's nothing to destroy. So I would recommend definitely trying to improve your soldering skills. And a lot of time, the problem with soldering is not because you're rubbish at it necessarily, but because the equipment you're using or the solder you're using is just not very good. I've soldered stuff with bad solder and it's come out terribly. You get some decent solder and it improves things no end. So leaded solder with a decent flux, like a 60-40 mix, is pretty good. If you can get hold of TBS solder, their solder is actually pretty decent. I use that quite a bit and I'm happy with it. So I would try to, get some decent solder. A decent soldering iron helps, and have a practice with a practice board. It's definitely a skill that you would need in this hobby. But yeah, so the final parts is we have this lead here to connect to something. So maybe that is for this UART here. So you have the pins coming up for that UART, so it's giving you a connector for that. So you can just solder to the wire end. And then we have another cable here, which is going to be, I guess, for GPS. That's the only thing missing. But again, you may have to switch stuff around with that. There are a couple of things just that I'd like to check before we wrap the video up. We wanted to see if these here were grounds, because potentially we could save weight if we don't have to use those copper standoffs. Oh, there's a ground in one of these, I think. Yeah. So I'm just tapping the pin. But yeah, it doesn't look like these are grounds. It looks like the ground is actually coming up through this connector here. So potentially, if you really wanted to save a little bit more weight, you could use nylon standoffs. Actually, let's just check. Yeah, so there is actually a ground on that connector block. So you could use nylon standoffs and save a bit of weight there rather than using the metal ones. Okay, so I've just put this together quickly, only connecting 2 of the boards up, but you can see the screws work. So if you didn't want to use the other baseboard and have it installed that way, you can. Right, so there we go, guys. I hope you've enjoyed the introduction to this little flight controller here. This is, of course, the bigger brother. What I was going to show before we go, this is an average sort of small size aircraft. This is a T1 Ranger, and you can see that flight controller in there actually is about the perfect size. Let's put the big one in there just as a comparison. So you can see with this, you've got a lot more room around it. It's a great size for this size aircraft. At the moment, my thoughts are that, yeah, it's probably a decent flight controller. It seems to be well thought out, other than maybe the connections. It would have been nice if there was a power switch for the VTX. That's the biggest thing I'm missing, especially with digital systems, which can heat up and also cause problems with GPS satellites. Other than that, it actually has more features than the big one, and it's $4 cheaper. So I think for small builds, maybe not necessarily light builds, it's a great option and definitely something that you can look at as an alternative to some of the other brands. I hope you've had enough information on here to make up your minds, but yeah, I think it's a good flight controller and I can probably see myself getting more of them. Until next time, thank you for watching. Fly models like you stole them. Have a great time.